और नहीं तो शुरू करने का हमको तरीका बता दीजिए, क्या करना शुरू में। शुरू क्या है, शुरू करना क्या, लेक्चर देना है क्या? वो तो ऑलरेडी वो वीडियो में चल रहा है लेक्चर। हाँ ठीक है, ओके ठीक है। आई थिंक दैट देयर आर ऑलरेडी, ठीक है, ओके। नाउ I think there was one question also in this one, but now how should I go ahead, because that student may not be there. Nikhil Goyal, it was asked by Nikhil Goyal. Nikhil Goyal is not present, no? And if they want that they will put the queries here, accordingly I will explain. Okay, so if is there any query actually first? Nikhil's question is there, but should I answer it? Otherwise, yeah. And I am not seeing anybody joining here in the this one Teams. Yes. If cutting post first, even the cutting post. Acha. Any question? Any question? ये जो है उसका टाइम लैग भी है ना? किसको? ये वाला? अच्छा ठीक है, ये तो नहीं, वो तो वहां टाइम लैग है, लेट से आता है ना? अच्छा ओके। नहीं, वो तो टीम्स में तो कोई आया ज्वाइन ही नहीं किया है ना? टीम्स में कोई ज्वाइन ही नहीं किया है। चैट में वो एक ही तरीका है कि वो चैट में लिख सकता है। टीम में जो कोई ज्वाइन ही नहीं किया तो नेचुरली यूट्यूब में ही लिख सकता है ना? तो उसमें फिर मिथुन कुमार ने ज्वाइन किया था, बट ही जस्ट सेड हाय and he is not asking any question, है ना? I think just इसको शेयर करके दिखा देंगे, वो जो है दैट आई थिंक 1 by 1 ना, बस यही तरीका है उसका, कोई ना। शेयर ना, इंटायर स्क्रीन, ओके शेयर, ओके include na. This was already I think told to them na? This is syllabus and books etc. Okay, then there is lecture 1 na? This one, stop sharing, okay, hide. This is about machining definition, additive, subtractive, mask containing. Our focus is on machining. Then we are telling that cutting tool is of a wedge shape tool, okay, like a wedge. Na? Why we make it a wedge shape? So that the force gets simplified. I am putting this one. What is mechanics? Yeah, this type of thing, that how you change that engineering strain to strain. Okay, this type of formula, this already has been covered, and they have done assignment based on this. Okay, right. So this is one thing. This one. Then we go to lecture 2. Okay, lecture 2. In lecture 2, it was about that some basic concepts about plastic deformation, because naturally that it is taking plastic deformation only. Okay, so now uh, uh, okay, so plastic deformation thing is like this. This location, school location. This is what that it has been covered there. So then finally that lecture 3, okay. Lecture 3 has been covered. Machining classes. ये जो है, this is single point, multi point, straight turning, running, broaching tool. Then this is the concept of generatrix and directrix. Because suppose you have got a tool, and tool is moving in this direction, and then it is moved, feed motion here is here. That means generation motion. That means cutting velocity is along this direction, and feed is along this direction. Then it is moving, and it will make this type of surface. Similarly, my tool can move in a circular path, basically. Actually, tool may remain stationary, but the whole thing will be moving, so it is like a circular path. And simultaneously, you are giving the feed by means of directrix. Okay, so then you are getting a cylindrical one. And the motion of this one, direction of line motion is in this direction, so it is going like that. And this is inclination angle. Okay, it is inclined here, so cutting edge is inclined with this direction. That means that basically y direction. Okay, that means this is the velocity. Okay, so that's what that this what the types of chips you get. Continuous chip, particularly in ductile material with low feed, etc. Continuous chip with built-up edge. That comparison table is also there. Okay, that is given. This is double turning. That means one tool is here, other is opposite direction. So it offsets the radial force. Then this is about surface rake, surface, etc. That means back surface of the generated chip. Okay, back side surface of the chip, and you are getting cracks, etc. Anyway, these are just micrographs. Span we fill. That means here I want to say there is a minimum undeformed chip thickness below which chip will not form. So you need minimum amount of feed is needed. Okay, this is the variation of surface roughness with cutting speed. Classification of chips by hertz. That one type, one discontinuous, then continuous, or even type, then continuous chip with built-up edge. Then mechanics of sawtooth chip. Okay, segmented chip. Chip blockers. Why do we put chip blockers like here, so that chip can get broken? This is the thing. Chip should be this one. Chip blockers, and this one, right? So chip blocker is this. Okay, this is lecture 3. Okay, then similarly we can go to lecture 4. That is about tool geometry, very important because understanding the geometry. But let me meantime see if there is any question. If there is any question, then we can answer. Okay, no, there is no question, but there are some maybe two, 3 persons are there here. Okay, but there are no questions here. Okay, similarly here, nobody had joined from the main this one, and it is yeah. This is tool geometry. Okay, tool geometry. Okay, yeah, yeah. Tool geometry is this one. We are cutting that basically by single point cutting tool. These are carbon fibers, cutting speed, and you are cutting like this. Composite material can also be cut. So that's what we are showing it here. Okay, that is cutting speed. Then this is the rake face. In the rake face, you get a crater wheel. Crater means basically pit, gadha. So that means that this is created by this one. And then sharp cutting edge is this. One point has to be seen that this is called single point cutting edge. Why? Because primarily that this edge is cutting. Other edge is not cutting actually. So here that what happens that if we say this is the main side cutting edge, this one, and this is the end cutting edge. So we can say that basically this is the flank wheel. So suppose one primarily if only one edge is cutting, then it is a single point cutting. But if both the edges are participating, then of course it is not a fully single point turning. Maybe with assumption you can say that it is like that. And the flank wheel you get on the that flank surface. Okay, that is what you are getting, crater wheel and flank wheel. Okay, so now we have that suppose principal cutting edge, main cutting edge, and this is auxiliary cutting edge. This is auxiliary flank face, and this is the principal flank face. Flank means side, and nose and shank and all those type of things. You make 3 views so that you can show the 6 angles and 1 nose radius. So nose radius will appear in the top view. Okay, top view you have got, and this is side cutting edge, and this is end cutting edge, and this is end relief angle. This is back rake angle. This is side rake angle, and this is side relief angle here. Side relief angle. It is just going a little bit down. That's why you are getting like that. So we make tool signature. In the tool signature, we have to show all these things. Okay. Back rake angle, side rake angle, end relief angle, side relief angle, end cutting edge angle, side cutting edge angle, and we get nose radius. Okay. So this is as per American Standard Association. And in orthogonal system, we have different system, but let us see that in orthogonal system, what we do that. First, we take that one reference plane. Okay, reference plane is perpendicular to the velocity vector. Okay, that means it is this one. It is perpendicular to the velocity vector, and cutting plane is that plane which is taking the cutting edge actually here. That is cutting edge is contained in that. And orthogonal is orthogonal is hello. 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 Why you are taking nobody is speaking then? Is it that? So is there any question till then? ठीक से बात करो. हेलो, आप बात नहीं कर पा रहे हो, ये भी मुझे उठाना पड़ेगा, आपको बात ही नहीं कर रहे. हेलो, हाँ यार मेरा भी एक प्रेजेंटेशन चल रहा है यहाँ पर. ओके, देखो बात भी नहीं कर पाते, वो कह रहा, वो बार बार बोल रहा. ओके, नाउ हियर let me see meantime if there are any questions, because I am not getting questions. I am just in a monologue way. Okay, fine, very good that there is some question. Nikhil Goyal. Okay, what? Acha, Muhammad Hassan is there. Very good. No, Mahmoud Hassan. Mahmoudul Hassan. Very good. So I think Mahmoudul Hassan had just given number. So that means he is also interested to ask the same question. Okay. Then very good, Mahmoudul. Thank you that you came and you asked this question. Question is that if cutting force, thrust force and shear force on shear plane is given, then how to find normal force on shear plane? So it is pertaining to orthogonal machining. No? Cutting force and thrust force suppose has been given. Okay. So cutting force and thrust force is the thing which you get basically in the machine. Okay, that means orthogonal cutting two components, you can find out the resultant, because resultant will be cutting force square plus thrust force square, right? And shear force and shear force is given, but shear force square plus this one normal force square is equal to also resultant. So you got one equation, cutting force square plus thrust force square is equal to shear force square plus normal force square. So normal force square can be found by this way. Okay. So it is yes. Hello, Ram. Yeah,
Yes,
Ram.
sir.
Yes. Yeah, you want to ask any question? Yes.
No, not now, sir.
Acha. Okay,
not now,
okay.
Sir.
Acha. Okay. Fine. Okay. So I am just showing you that some slides then, and if you have any doubt, then you can ask. Okay. Like I have got two questions, two persons asked, but I have answered that. What is the cutting force and this one? Let me just show my slide. Okay, here you have this one, orthogonal system. This is oblique or normal reference system. So oblique system, what will happen that you will have one plane will be the cutting plane. No? That means it contains the cutting edge, but also it contains that one plane which is normal to the cutting edge. Okay. So therefore there is some differences. So I just have taught you already in video that the angle from one system to the other system. Okay. In fact, here I am highlighting that suppose precisely if cutting velocity is this, but you have some feed velocity also, then the resultant velocity will be like this. And actually reference plane we say like this, but effective reference plane becomes like this because it is perpendicular, so some difference is there. So some amount of change in the angle, rake angle occurs if you set the tool above the center or below the center also. That type of thing is also there. That's what I am going to, I have illustrated here. Okay, fine. Now here, so we are having tool nomenclature system, but in each system you have to have 6 angles and node radius is common. Okay, so node radius is common, right? And this is maximum rake angle system, because see, you suppose in SA system you have got side rake and you have got back rake, but the maximum rake will be different actually. So that maximum is that in one direction where you get the maximum slope. So that formula also I have written to you, and these are just typical angles in different materials. This also has been covered. Okay, so this much was covered up to lecture 4. Okay, so let me just go to lecture 5. I summarize that in video, and then you can have any question if you want here. Conversion of two angles. Yes. So how to convert the two angles? ORS, maximum rate system, is British system. NRS is called international system. Although it is called international system, but practically everybody is now following American type of system. That is more common, but you may have some books or something. So that's what now it is. I am showing different type of relations. I will tan I is equal to this one. Say suppose one system to the other system. Inclination angle, how you find out from here? In orthogonal machining, inclination angle will be 0. Okay. ORS to normal rake system, like normal rake angle tan alpha n is equal to cos cosine I into tan alpha 0. Okay. These are the formulae. Of course, that there is some mathematics trigonometry. This is the maximum rake angle. Tan alpha m is equal to under root tan square alpha s plus tan square alpha b. Okay. Side rake angle square plus back rake angle square. These two things are very important. And this is what it goes. No? So now, okay. What is that? This is so these are the about other tools like cutter is there, helical cutter and all those type of things. And these are the this one. So this also I have covered. Okay. Let me just check that if there is any question. Yeah, it is.
Sir.
Yeah. Yes.
Sir, in cutting insert, if you see the cutting insert, we cannot find means we the tool geometry is not like the conventional single point cutting tool.
You mean to say there are some groove and something like that? No?
Yeah, in insert.
Yes, insert. No. Basic things are same, but you know they may have some little bit additional things also. But basic angles are there. But what happens? Insert has to be mounted, and then after mounting, you have to see the angle. It is the tool may be anything, but it depends that how you have mounted it actually. But as such angles are you are not able to see probably because some of those angles will be very small. Say for example, side rake angle may be 0 actually. So it will not be visible to you actually. Is it not? And then some other design you see in this one, that is basically chip breaker actually. Some group type of thing. But as such basic things is same. It has to be there because the tool is always a wedge shaped thing. Like a wedge. Basically it is edge. So one surface has to be inclined, otherwise it will start rubbing. Anything I can make a tool. You see that this is today I have got some cold, so this is mix this one thing dibia. And now if you see here, if you take this sharp edge, by that I can cut actually corner. So when two surfaces are meeting, then only you will make the cutting edge actually. That is the basic principle actually. Any two surfaces they have to meet. So in the cutting insert also, there are two surfaces. So one surface will be called the rake surface on which the chip will flow. Other surface will be called basically side flank surface. Okay. And they have to be some angle is there, but those angles are very, very small also. So you have to see in tool maker's microscope. Okay. That is how that it is this one. But anyway, let us go to that. Now I am going to lecture 5. I have covered, and let me just show you lecture 6 up to 11 we have covered. This is mechanics of orthogonal cutting, very basic. In practice, we don't do that type of thing cutting, but you know that we are just showing that. So you have to have the wedge shape tool. Okay. This wedge is cutting. These are the relations like shear angle. We assume that the shearing is taking place like this. and this is the cut thickness and uncut thickness. And uncut thickness is T1 and cut thickness is T2. So T2 will always be greater than T1. So cutting ratio will be always more than it will be type of thing. Now maybe you may have some tool where this edge may not be completely straight, it may be inclined, and these such type of variation can be there. But the basic thing will remain that this surface has to be inclined with respect to the perpendicular to the cutting velocity. And then you have this one and this you chip thickness. Now this is a simple that one. See, somebody was asking this question only, that suppose we have Fn and Fs. So if you square them, it becomes the resultant. Similarly, F square plus N square is equal to also resultant. And similarly, cutting force plus thrust force, that is also resultant. So that means you have got these equations. So if you know one component, if you know three component, you can find out the fourth component. So this is FC and FT are this one, and this is yeah. So this type of thing was also told, and we have told that merchant analysis. This actually very approximate model, no? But merchant second analysis was like this, that here they said it is that they, because Bridgman said that it is also dependent on how much normal stress is there. That means here stress will change with the normal stress. So he gave this formula. So with that, some changes will take place, and that analysis has been done. And I am not going to repeat that. Okay, that is always, yes. These are the problems. Okay, cutting force and this one. These are the F by N ratio. We assume that Coulomb's coefficient of friction, but in practice, it is just approximation because Coulomb's law is not valid there. But still, we assume that ratio average force is equal to tangential force, and this is average normal. Okay. So this is what we can, yes. Now this is very important point, Pathak. Pathak ji, you say pay attention to this. I have seen, I ask many people, this is when they are doing turning, whether the feed is affecting the chip thickness or depth of cut. Many people think because this has been given, so depth of cut is affecting the chip thickness, but it is not so, because cutting is being done like this, okay, in this type of direction. You just see. So therefore, T1 is proportional to feed into cosine psi, where this is side cutting edge angle. That means you can observe that, you can measure the chip thickness. You will see that basically the chip thickness will be increasing when you increase the feed. In depth of cut, it is not dependent that much. Depth of cut will affect the chip width actually. So this point is very, very important here. So therefore, it is this one. But many people suddenly they say that because in our with this type of figure, because this is here it is the chip thickness. This is like that because it is going like this. So they think that in the turning also depth of cut will decide the chip thickness. But it is not that. Depth of cut doesn't decide the chip thickness. Depth of cut will decide the width. So you have, that's why that this diagram is made here, and these are the conditions for orthogonal machining, and this is feed force and radial force. Yeah. So if you know, if you are getting thrust force on the cutting edge, so sometimes we can say this one, that feed force is equal to Ft cos cosine psi and radial force is equal to Ft sine psi. Okay. So this was like that. This was told in this lecture, and yeah. So if there is any, let me see in YouTube if there is any question in YouTube or in that this one. Yeah, Mahmood has already asked question, and he's from this one industry, and then this one. Yeah. here, okay, there are many people watching now. Okay, no problem. Okay. Now YouTube is also where people are watching. Fine. Now I will go to this one. Up to 6th we have told? No, not yet. No, 6th has been told, yes. And then we have to go to 7th lecture. This also has been covered. Strain and stresses actually in orthogonal machining. Force divided by area gives average stress. Okay. So here I am telling that coefficient of friction mu is equal to tan lambda friction angle F by N, and this is how you are getting. And force, but actually they are not uniformly distributed. That is different thing. In practice, you will get this type of situation. Suppose this is the cutting point, cutting where you are doing cutting. This is the rake surface. So normal stress keeps on decreasing like this. Okay, it keeps on reducing like this, and shear stress remains here. Here the shear stress is very high also, but shear stress cannot increase beyond the limit. Particularly, suppose the shear yield stress of the material is there, it cannot cross that. So there it saturates. That means in this zone, it doesn't follow any Coulomb's law. Rather, the shear stress remains constant. It is no longer proportional to normal stress. But after this point, shear stress is proportional to normal stress. Okay. So this is how that it is showing. So shear stress is actually changing like that. But all that type of things in simple model, we do not do that type of analysis. We just take average shear stress and we say the normal stress. But this is what that one has to remember. So here I am just showing the general thing that normally, you know that when normal force increases, then friction force also increases. That's what we have studied in school. Because Coulomb's law, right from school it is start. Class 8, 9, 10, 11, 12, everybody uses that. But it is true up to certain limit. That means normal force is not very high. Moment normal force becomes very high, then there comes a limit. After that, everything becomes flat. That means you keep on increasing the normal force, but the friction force will remain same. And in between there is a transition zone. So that is the situation. It can be taught from the stability model. So that's what I have written that. There is one Winningham and Bayes friction model that captures this type of phenomena. Okay. So this type of thing was told. And then also another aspect is there. This is just basic nature dependent on the load. Another thing is that friction may dependent on the cutting velocity. So F0 VC to the power P, where P is negative, say point minus 0.07 like that. Increases, then the friction force decreases. Okay, let me just see that if it is a going on. Okay, fine. So any question? Yeah, Dr. R. Rajkumar. No? Dr. R. Rajkumar also has joined. He said that Sufen also was. Okay, now let me see in YouTube. Anybody is asking anything? Where is YouTube thing? Yes, YouTube. Yeah, they are watching, but no question till now. Okay, so here, so up to what we have done, this is done. So we are telling that friction dependency of this one. Yeah, friction angle, determination of stresses. Yes, see, shear stress Fs divided by As. So you find out Fs by the formula. If you know through dynamometer, if you measure the cutting force and thrust force divided by the area Bt by sin phi, you get the shear stress, and normal stress similarly you can find out. Okay, so roughly you will get idea. And shear strain will be like this. Shear strain cot phi plus tan phi minus alpha. Now remember, alpha is the exact rake angle. That is of course known to you. But phi is just approximation. You cannot measure it directly. unless you put a very high arrangement and you put the camera and then you do that some machining, then you stop the machining, then you can measure the phi. But the phi is not measured. Moreover, it is also not correct that don't think that the cutting takes place at a line. It will be very blurred, no, type of thing. But still we assume that on an average it is goes like that. So it is found phi indirectly we find out by measuring the chip thickness, etc. Okay. And then shear strain is given in terms of the chip compression ratio. Chip compression ratio is the opposite of cutting ratio. So cutting ratio is T1 by T2 and the chip compression ratio is T2 by T1. Tool rake angle alpha can be expressed as this one, and this is the shear strain, and this one will be like that. Okay. So chip compression ratio, if it is known to you, then you can find out shear strain. Okay. That means this is this one. So here this expression has been given, and you can see that shear strain. Suppose I keep on increasing the rake angle, then my shear strain decreases because minus alpha. And if the shear strain is decreasing, in a way it is good also, because you want to cut the material. You don't want to create much strain actually. It should automatically, because whatever you have, it is not a metal forming that where you want to do strain and that will be useful for you. That material is gone. So any cutting process which cuts without producing any strain, that is better. But you know, minimum strain will always be there. That is this one. So we are showing that how do we find out expression for this. This is shear strain rate. Shear strain rate unit is per second. So here we say, assume that the separation between two successive planes is 25 into 10 to the power minus 4. So shear strain comes out of the order of 10 to the power 5 per second. Test, the shear strain rate is 10 to the power minus 3 per second. That slowly you consider. 10 to the power minus 3 per second strain we use. And if impact test is there, then it will be 10 to the power 3 per second, 1000 per second. That much we can get. But here it is claimed that it is 10 to the power 5. So as the code doesn't agree to this actually. There are not some researchers I have indicated that they said no, strain in metal cutting is not very high. So what I am telling, if anybody wants to do fundamental research, still this area is open. Anybody can do research here. That it is, they just said that in metal delta Y plane spacing is this much and put that, but nobody is actually seeing that thing. This one, either you need very sophisticated instrument and you have to realize the whole cutting process. That is why the scope is very much this one. Chip velocity. Okay, this is about velocity, shear velocity. This much also has been told. And then, so this paper I told, this paper, it is still not has come in the textbooks, but it is worth reading paper. It was published in very reputed journal, International Journal of Mechanical Sciences in 2005. It is a very big paper, but very easy to understand. He said that what are the problems with the single shear plane model? Means by assuming that the cutting is taking place like this is fine. So that's what he is saying that. And then he said that it will produce infinite strain rate and unrealistically high strain, shear strain and shear strain rate. He says that this much high it is producing, and then behavior of the work material is also not proper. And then he said many things. So he said he showed a lot of drawbacks, and which is contained in the video. And then he's saying that force diagram is also incorrect. And then more say that type of friction model we generally take, although the mu should not be greater than 0.577, he says, but you know that in machining generally we take mu very high and we do something. So he is supporting those ideas. This one, and see here he says constant friction coefficient. Obviously it cannot be constant. So there were other people also who did this one, like Briggs model was there. There he said that it is like a fan, cutting is taking place like in this zone. There is no CL plane, rather there is zone. And Jolo model, Jolo said that zone is like this, okay. This is Jolo model. Then Jolo simplified model, he said, okay, this is very complicated, so you can simplify a bit and you can say that like this. At least you should consider. So this is the formula, so that during orthogonal machining with a zero rake angle, shear strain is given by this. Okay, that is given. So this point I have highlighted. Lot of research potential is also there. If you follow Astko's papers, Astko has written many papers. He is a Russian but settled in America. He has written many things. Experimental study of orthogonal cutting and other models. So different models, actually there will be plastic deformation, this and the cutting zone. So here how to determine that chip formation, how should we do that? One is that we make the circular grids. Earlier people used to do this type of thing. They will make grid on material, and after deformation they will see what happened to the grid. Okay, and then they used to make the circles, and now after deformation circle will become ellipse. If you want, still the students can do such type of experiments, but nowadays this type of research was very popular in 1970s, etc. After that, nowadays people are not doing, but high photography. So that's what, suppose it becomes circle, becomes the ellipse, then you can find out the strain like this. E1 is equal to ln R2 by R, and this is equal to this thing. Other thing is the method of frozen chip. You are doing cutting and somehow suddenly you withdraw, and then see what happens, how the chip is connected. That type of experiments also people have done. So I am not, some people have said that, okay, suddenly they put some spring here. So with impact, it suddenly gets broken and detached. These type of concepts are there. Okay, I'm just telling the concepts. Here he is putting the CL pin. So you are doing machining, and suddenly the CL pin will get broken. So workpiece and tool will get detached all of a sudden. And then you can see that what happened. So these are something like quick stop test or frozen quick stop operators like this. And indirect method of shear angle measurement is that, of course, you measure the cutting ratio. This is called the cutting ratio, and its opposite is chip compression ratio. Okay, that means 1 by R is equal to this one. So they say this is the formula. So therefore, if you know the cutting ratio, you know rake angle, you can find out phi. And then uncut chip thickness you can do by weight measurement also, because in plastic deformation the weight remains constant. So that method also has been told. And cutting, but we are assuming that cutting edge is very, very sharp, but cutting edge may also vary. So what our Pathak ji asked that is this one also correct. He said that when I see any tip, etc., then I am finding that these angles are somewhat different. So there may be many other features, like the edge radius is also there. Remember, it is different from the node radius. One thing is node radius that you see in the top view, but in the side view, but in the side, from side also you can see the radius, that is edge radius, and it may be very, very small, but it has some effect actually. Okay, that are the performance. So that means, and this is the generally that this diagram, that this is primary shear zone. Actually, this is a shear zone, but you are just assuming that it is a shear angle a bit way, and maybe you are ignoring a lot of zone here. You are just saying this one and chip, and this is secondary shear zone. Okay, here chip is sliding, and this is tertiary shear zone, small, that is about the clearance. Okay, so this is paper by this one, and friction may not be constant at the rake surface. And then Atkin's paper is also very useful. Atkin in 2003, he has published very good paper that is also in the same journal, International Journal of Mechanical Sciences. Here he says that you do any machining problem by energy approach. So you see that work required for plastic deformation work due to friction at tool chip work interface, and some work is to be done to separate, make a new surface, because the surface, something surface energy increases. So for that you have to do that. So this type of thing was not added. So he said power for creating new surface. That if you add, then it will solve many problems. So that type of things. I have asked some of my PhD students to do some work using that model, and it was giving good result actually in that case. That means one additional parameter has increased. But even again, there is a scope for research, because it is true that I added this thing and I got good result, but it may be just a type of some kind of fitting type of thing, because two things. Really, it is this surface energy coefficient or not. For that, you have to do some physics study also. It kills models, so energy of cutting. There are some empirical models. People said all these models, they do what? That cutting force is proportional to that feed and this one. So here it is not this one. It is T to the power A and W to the power B. So it is not that A will be 1 and B will be 1. It may be something. Then I told ship line model. It is a general method for solving such type of problems. Nowadays, not that much popular. That here, that suppose you want to find out the shear stress. Okay, so shear stress K, and this is this one. So they assume that material goes along some shear lines. Okay, wherever you get maximum shear and you get hydrostatic stress there. So something about slip line theory also I had told that, which is not taught in the BTech, but I have told that you have to satisfy basically the equilibrium equation. That means this one continuity equation, and this is the rule of plastic flow. Then what happens that I told that how it can be done is some analysis based on that. Then we have done this much I told in this lecture, and this was lecture 8. Then I think I have covered lecture 9. Huh? Lecture 9 I covered this topic. These it is still the machining. If somebody wants to do fundamental analysis, then in machining the area is quite open, because most of the work people do, but they are not understanding the mechanics. Main objective of metal cutting. So other analysis: analytical, experimental, mechanistic, numerical. Okay, like slip line field theory of Angele. These type of things are slip line theory. They can take strain hardening also. But mechanistic model, there they say that FC is equal to something like, it is something like semi-empirical type of thing. KCC times T1W, KEC times W, means this is the H coefficient and this is the other cutting coefficient, but these may be dependent on the geometry. So there is some mathematics here and something you have to do by experiment. That is why they are called mechanistic model. So these, and then energy approach, and this is power due to friction, finite element modeling. But of course, now why this research, this type of research also can be done, but now people are trying to do finite element. That's why that this type of research has become somewhat this one. Yes, but finite element also, it is not so easy. Even if you do that, I have told that some theory about the finite element formulation here in this lecture, which I will not repeat, but what I am telling that nowadays you use packages. In the packages, automatically the things are done. But one may take much time actually, maybe 8 hours, 9 hours, and you will not get result. So you have to, it is not, you have to put some effort. It is not so easy that within seconds you will get answer. And so this is mechanics of oblique cutting. Oblique cutting means angle, there is, it is at angle. So in a oblique cutting, you get some other type of ratios that I have explained here. And this, so in oblique cutting, that basically it is a 3-dimensional cutting. So this chapter is, I would say that this is somewhat most difficult chapter of the whole like this one. Because why? Because you have to visualize 3D things also. Even though I have tried to explain each and everything, but you have to say visualize, maybe you have to put your own model that measure, and then measurement of chip flow direction. Indirect measurement, direct measurement. Chip flow is also not like this straight, okay, perpendicular to this one. So chip flow angle is also there. So direct measurement, indirect measurement, and this is the thing. Sometimes when people make the assumption that inclination angle is equal to chip flow angle, and finally we had done this one, measurement of cutting forces. Now see these type of methods, even today also people can use that, strain gauges, etc. But now Kisral dynamometer has become very famous. So earlier they used to do that ring type of thing, that if you want to measure the force, just deform the ring, and here you put the strain gauges, and then you can have this type of thing. It becomes ellipse, and ultimately you have to use wheat stone bridge actually. So this is the something I have told, that is this one. And you can have spring type of things also, simple spring type cantilever type thing also, and you can put the strain gauges here, and this is Kislar's dynamometer. It uses piezoelectric thing. So since it uses piezoelectric thing, so it will be very accurate compared to strain gauge things. Strain gauge also, it is not so easy. I have said strain gauge, but you know, if you do not fix it properly, you will get wrong reading. Okay. So here also, it is a very sensitive instrument. If somehow once I purchased, and because of humidity here in Guwahati, this had spoiled that cable, etc. So it was giving a lot of noise. Then the service engineer came from Singapore, and he put the cable in some oven, and after 1 hour it was dried, and then this one like that. So it is not, and this is the charge meter provided by them, because they are basically charge amplifier. Because charge is very small, which is amplified. And these are very costly, of course. So if you want to do crude experiment, then you can use strain gauge also. So one student did some PhD, he put the front tool and rear tool on the opposite sides, and then he took the typical reading from this one. And these are some other force measure techniques. Many force measurement techniques are there. So somebody who is interested in metrology, he can actually measurement, he can use this type of thing also. So it is yeah. So this is all. If there is any question, you can I can answer. Otherwise, the purpose was just to interact. Everything is going on through video lectures. Okay. So you can always see that. Are you seeing the video lectures? Pathak, you are seeing? No, you are muted. You are muted. You are muted. You are here. You are muted. Yeah. You unmute yourself. Yeah.
I have, sir, taken a print of the notes.
Print out of the notes, actually. Okay.
Yeah, yeah.
Then you have to study that.
Yeah.
Okay, okay.
And sir, yesterday, day before yesterday, that Lee Sefer slip line theory, the formula was given FC KBH 1 plus cot phi. But in the notes, I have seen K is not there.
K got missed in the notes.
Yeah, with the notes.
Acha.
Only KH, B is not there.
B means beta, beta.
F is equal to KH 1 plus cos phi.
In slip line. In slip line, na?
That Lee Sefer. Lee Sefer slip line.
So it got missed. Lee Sefer's, what is that? Lee Sefer's formula is this one, na? Where is that thing? Lee Sefer correct equation is this. That is
F equal to KH 1 plus cos phi.
FP, that Lee and Shuffle, na? KBT bracket close, cart 5 plus 1. That one, na? Cart 5 shear angle. B means width, and K means that shear strength.
Shear strength.
And FQ is equal to KBT cos phi minus 1. Na? Okay. So you can collect that. Okay, because both the things have to be there. It is proportional. Lee and Shuffle theory tells only that force is of course proportional to K, and B and T also. And then this is cot phi minus 1 and cot phi plus 1. Okay. So that is what that this one. Okay. Maybe that, yeah. So this is, yeah, that you can collect actually if it is coming. And then phi is equal to pi by 4 minus lambda minus alpha. So some difference is there. That shear angle. Shear angle is equal to pi by 4 minus bracket lambda minus alpha. Okay. Or phi plus lambda minus alpha is equal to pi by 4. Okay. So this is this one. So yeah. But so there is a linear relation between phi and lambda minus alpha, and okay, but it is not very correct that at low rake angle and something that is also written. Right, because it is assuming that there is no built-up edge. So that type of thing you have to be this one. Okay, so that's how that I think that now the time is over, that 1 hour only. Okay, so here also that we have in YouTube, let me just see that if there is any. Yeah, there are some people here, but and they have not. Let me see if anybody asks question in through the another forum. Actually, this is the thing. So yeah, only these 2 questions were there, but let me just see, refresh it. Okay, fine. So okay, Pathak, na, all the best. You are appearing the exam or not?
I have applied for. Yes.
Okay, exam, fine. So based on the basic concepts, it will be multiple choice type of only. Okay. Multiple choice.
Sir, if I recover from my spondylitis, I will appear.
Okay. But the question paper I made easy only, right? Okay. So therefore you can easily this one, because even some conceptual questions and no negative marking. Yeah.
Okay.
So no negative marking. So easily you can get a certificate. Okay. So I think you will pass. Okay, fine. Okay then. Okay, fine. Okay.